section 3.2, we're talking about measures of center, and I'm pretty sure you're familiar with all the words in that section. You probably would have done fine on the reading quiz even without my template. But I have something for you to think about for a second. Group A consists of 5 students who took a test. Their scores are 70, 70, 70, 70, and 70. What's the mean score of Group A? 70. You add all 5 70s and divide by 5, you're going to get 70. Group B consists of 5 students who took a test. Their scores are 85, 85, 85, 85, and 10. Guess what their mean score is? You could add it up real quickly. This is 170 and that's 170, so that's 340, and 10 is 350 divided by 5 again. Their mean is 70 as well. And then Group C consists of 5 students who took a test. Their scores are 70, 80, 80, 60, and 60. Guess what their mean score is? Also 70. Which group would you say did the best? They all have a mean of 70, but, you know, if you're the teacher of these 3 groups, which group are you going to be the happiest with? All right, consistency might be a good thing, unless it's consistently bad, and then consistent's not a good thing. Consistency can be good sometimes. Anybody have a different feeling about which group you would be most proud of? I think Group B is probably the one I would be most proud of, and I'd just write this guy off as a knucklehead. You know, the other 4 did great. So obviously it was a fair test. It wasn't a difficult test. 4 out of 5 of them made 85s, and this one just showed up to take the test high or something. So it's debatable. It's debatable. Mean is not always the best measure of center to represent how a group actually did, because all 3 groups had the exact same mean, but they did very differently on the test. Especially Group B is significantly different than Group A and Group C. So once again, in statistics, things aren't always as simple as you would like them to be. There's no right answer, by the way, to this question, which group performed the best. It would be a matter of opinion, you know, what you value. Do you value 4 doing really well and then just not worry about that other one, or do you value consistency? That's a personal decision. Let's talk about this PowerPoint. The 2 words that I thought, if you made up your own study guide for 3.2, you may have not had on there. Those were the 2 I was concerned about. In 3.1, there were 2 bold-faced terminology or terms. One was inferential statistics and one was descriptive statistics. Did you happen to have those on there? I thought you would, because they were in bold-faced type, but I just want to be really fair to everybody. Descriptive statistics describe a characteristic of a sample or a population. Some descriptive statistics are mean, median, and mode, which you're probably very familiar with. But descriptive statistics are just describing the population or the sample, not using those descriptions to make any inferences or any generalizations. Inferential statistics, coming up in chapter 5 very shortly, we're going to take those descriptive statistics like mean and use them to make generalizations or predictions about a population. So that's the difference between descriptive statistics and inferential statistics. 3.2 is measures of center, and there are different ways to get at the heart of data and determine the overall measure of how a group did. I like this cartoon. What is an average? My average student's doing great. Half my class thinks 2 plus 2 is 3, and the other half thinks 2 plus 2 is 5. Well, if you average this wrong answer with that wrong answer, you actually get the right answer. So that's one way of looking at it. I wouldn't feel so good about that. A measure of center is just the value at the center or the middle of a data set, and the one that you're probably most familiar with is the arithmetic mean, or most often I'll just say mean. It's the measure of center obtained by adding the values and dividing by the total number of values. It's what most people call an average. Every once in a while, probably more than I should, I'll accidentally talk about the average, and when I do, I'm talking about mean, but average is not a statistical word, and mean is. These are some symbols that we're going to be seeing in a lot of formulas this semester, and you really need to know what they stand for. Even though your calculator is going to do almost all of the calculations for you, I can only really think of 2 formulas all semester that your calculator doesn't have a button for, but still, I want you to understand what your calculator's doing. And to understand that, you need to know these symbols. This is the Greek letter capital sigma, and it means the sum of. So whenever you see that capital sigma, some values are being added up. X is the variable used to represent the individual data values. Sometimes you'll see X with subscripts. X with a subscript of 1 is the first data value. X with a subscript of 2 is the second data value, and so on. Little n for the whole rest of the semester is going to be the number of data values in a sample, and capital N is the number of data values in the population. So you'll see those symbols in the formulas coming up. For example, X bar is the mean of a set of sample values, and another Greek letter for you, mu is the mean of a population. To get a mean of a sample, you just add up, that's what the Greek letter sigma means, you add up all the data values and you divide by the number of values in the sample. So sigma x over n is saying what you already knew was the right way to find the mean. Just add them up and divide by the number in the sample. The population mean, mu, you add up all the x values and divide by capital N, which is the number in the population, not the number in the sample. It's going to be important all semester that you know when you're talking about a sample and when you're talking about a population and which symbols go with which. The advantages of using a mean is that means of samples drawn from the same population don't vary as much as other measures of center, and they take every data value into account. If I'm finding the mean weight of U.S. citizens, and I use sample sizes of 100, randomly chosen sample sizes of 100, and find the mean of each sample, then if indeed I have done a good job of randomly choosing my sample people, then no matter how many different samples I take, if they're simple random samples, the mean will be about the same for all of them. It doesn't vary very much. Disadvantage is that it's sensitive to every data value. One extreme value can affect it dramatically. That means it's not a resistant measure of center. It's not resistant to those outliers. The group B, was it, that 4 people made 85 and 1 person made a 10? That 10 was an extreme outlier, and it pulled the whole class average down 15 points. So mean is very sensitive to outliers, and that's something that you have to watch out for and maybe compensate for in some way. The median is the middle value when you put the original data values in order. It could be increasing or decreasing. It doesn't matter. You just have to put them in order and then pick the middle one. If there's an odd number of data values, then there'll be an exact middle one. If there's an even number of data values, there's not going to be an exact middle one, so you have to average the middle two. Just choose the middle two, add them, and divide by 2. The symbol for median is pronounced X tilde. That's what the little squiggle on the keyboard is. And it's not affected by an extreme value. It is a resistant measure of center. If I took those Group B scores, 4 85s and a 10, put them in order, then the exact middle one is 85. And in that case, it's a better reflection of how that class did than the mean actually was. Find the median, already said that. Put them in order. If there are an odd number of data values, it's the exact middle one. If there's an even number of data values, then just find the mean of the middle two. For example, that set of data has 12 values. Since 12 is even, there's not an exact middle one. Are they put in order? Let me think. Oh, this must have been the original data's, and this is data values, and this is the same data values put in order from lowest to highest. Since there's an even number, 6, then the median would be the average of 0.73 and 1.1. The median's 0.915. However, if you have a group of 7 data values and you put them in order, then there is an exact middle one, and the median of that set is 0.73.